Enate is a robotic service orchestration platform that lets you mix humans and bots seamlessly to deliver one end-to-end automated service. This is an HR demo that takes you through the process of onboarding new joiners into an organization. The simplified example comprises of two steps, one performed by a human, another by a bot. A UiPath bot has been used here. However, bots from any of the RPA tech leaders such as Blue Prism, Automation Anywhere or others can be used. Let's start the demo. We'll first log in as a user who's an ops manager or a team owner. This user has the responsibility to deliver the service and owns the team that delivers it. On login, this manager can see the human resources in their team and the number of pieces of work assigned to everyone, the unassigned work that is building up and needs to be planned for, the two bot farms that the team owns, one UiPath and the other Automation Anywhere. Clicking on the UiPath farm shows us it has 4 bots, 3 of which are busy and working and 1 is idle. The yellow marker on top shows 15 minutes of work pending for these 4 bots, after which time the bots will be idle. Team owners can use this information to consider other items that can be automated, or they can share these bots out to other teams that need capacity. The business can even evaluate using bots to work for other geographies to maximize utilization in different time zones. Everything in the system is color-coded to red, amber and green, based on SLAs and TATs. One view is sufficient to manage overdue work, those which are due today, or ones that still have time. The key takeaway is that Enate provides a single control environment across all resources involved in service delivery, and ultimately manages what resource is doing what work, where, when, and why. All of this ensures that Enate optimizes the utilization of resources against the business SLAs. We'll now log in as an HR user responsible for day-to-day work delivery. This user will approve a piece of work to add data of a new joiner into the underlying HR platform. All users and bots get work through pull-based allocation, which is the default. Push allocation can also be configured if required. The user gets the next piece of work by clicking the Get More Work button. The HR user checks the data. These are smart cards, also viewable on smart devices. The agent approves the addition by hitting complete and moves on to the next task. The HR user does this again to create a duplicate. This will demonstrate a success and a failure scenario where the bot successfully completes an update into the underlying HR system the first time and subsequently fails in the second attempt since the user already exists. The piece of work have now moved on to the bots for execution. On selecting the bot farm, the user can view the available bots. It is in this context we can see whether the bot Marvin has been assigned the update employee database piece of work. We are now looking at the UiPath bot environment where the bot has received the update employee in HR system actions. The bot performs the necessary routine as defined for it. The bot first searches for the employee, doesn't find it, and then creates it from the details provided on Enate. On the second pass, the bot finds an employee with the same name already created and aborts the create transaction since the new joiner's details already exist. The success or failure of the action is reported back to Enate by the bot. Moving back to the ops environment, the case is highlighted in red on the HR user's homepage indicating that something is wrong. On checking, it is highlighted on the right top that the bot could not complete the action. The human can then take decisions based on the corrective measures prescribed. There are multiple options around this. They can add a note, skip that specific bot action and let the process continue onwards. They can start a piece of communication around that piece of work, for example saying something like the employee already exists in the database. They can fix the data if something needs to be changed and then ask the bot to rework that specific task. This takeaway is that the human user really is in control of the piece of work and can choose how to deal with it without worrying about bot scripts or how to work around them. The key principle is that the work remains in the operations world without relying on IT and can be seamlessly flipped between humans and bot multiple times. This to and fro activity essentially allows human users to treat bots like true team members and can step in only to handle exceptions or use those skills that are outside the scope of what the bots have been trained on. One last point to understand about Enate is that it will automatically take corrective action and keep track of bot activity. For example, if a bot fails a task, it is rerouted to human. If a bot continuously fails a task, Enate stops sending the task to bots and routes it to humans so the bot routines can be fixed. Enate is aware when bots are taking too long or have become unresponsive. And Enate is aware when a bot is busy with the work that is assigned to them. The main message here is that when the bots go down, you have technical as well as service outage. And Enate gives you a way of handling both. Humans can get on while IT serves with bot outage. Queues on Enate represent competencies and are pools where work items arrive. Human and bot resources are added to queues against those competencies as and when they gain those competencies. Resources receive a piece of work from queues they're assigned to. Team owners can also push work to users or bots at any time. This also gives operations control on how and where to apply spare human and bot capacity they have during peak hours or unplanned leaves, for example. The key takeaway is that work is auto-prioritized and intelligently allocated by Enate based on competencies to optimize the delivery of SLAs. Both humans and bots receive and execute work in the same way, and all execution metrics are uniformly collected across humans and bots. We'll now see the configuration environment. This is Enate Builder. These are service lines. Under a service line, several processes can be defined. For example, in the onboarding service line, there are two processes, new starter and feedback. If you have multiple contracts with a customer, then each contract can be independently modeled. In this example for the Agricultural Bank of China, you have two contracts, one supporting their global business unit and the other Chinese business unit. The orange bars at the top are steps. The blue blocks are the actions in the process. Enate facilitates standardization at step level, but provides the facility to change the flow of actions and the various checks within actions for different geographies, business units, or customers. In this example on screen, we are looking at the new starter process. The process has been simplified to two actions: HR approval performed by a human user and the update employee database handed over to a UiPath RPA bot to update the underlying HR platform. Service level agreements or SLAs can be defined for the whole process, or it can be defined for each individual action. Enate provides various methods of calculating due dates. They can be configured based on supplier's calendar, customer's calendar, or against multiple supplier and customer calendars. Calculations can be done in various ways, such as 3 days after month end or 5 days before cutoff date. And activities can be automatically launched on a predefined calendar of dates. Enate provides custom cards which allow you to define a lightweight collection of data fields. Only minimal detail that is sufficient to identify the resource that should work on it should be included. For example, an ID. You can also integrate web interfaces from other systems that use SSO into a custom card. In this example, a Google form has been exposed inside Enate to provide a way to capture structured data to use downstream with bots. You can also use this approach to reduce multi-screen working where feasible. We'll now look at the bot integration. We'll start by looking at the bots available in this queue. There are few bots, Dex for example. We now move on to the UiPath orchestrator, create a new environment demo in the evening, and add a new bot, testing 123, to the environment. Where an orchestrator is available, Enate automatically synchronizes and maintains an up-to-date list of bots in real time. If we now head back to the Work Manager queue and look at the list again, the new bot added to the bot environment testing 123 is now available in this list and can be used in this service. Enate comes embedded with Tableau dashboards and provides various insights based on real-time data. Broadly, MI is categorized into three areas: Operational MI, Resource MI, and Directional MI. Operational MI reports on the performance of the service. Various parameters are reported on, such as timeliness, SLAs, performance against benchmarks for tasks, volumetric, productivity of an individual as well as a team, transaction volumes, communication volumes, performance against benchmarks, busy times of the day, and so on. Ultimately, these are the inputs you need to identify operational risk and manage and improve the quality of the service. Resource-based MI provides the productivity and utilization of resources. This view is a bot team view. The same is available for human users as well. In this graph, the x-axis represents capacity available and the y-axis the productivity. Resources at the top right quadrant indicate that they are highly utilized and highly productive. This is where you want all your resources to be. The size of the dot represents the number of defects they're reporting. If you have resources in the bottom left graph, this means that they have minimal availability and have hardly any output. This is an indication to question if these resources are adding any value to the business. Lastly, directional MI helps organizations plan areas which can be automated next. The dome at the top shows types of human skills in use in your tasks. The green section is follow basic rules, ideal for RPA type of bots. The brown on top is read and comprehend, ideal for an NLP type of bot. So if you invest in any of these technologies, then it will take out a percentage of these many units of work. The bar graph on the left bottom provides the rough cost of delivering these activities. The activities on the top cost approximately £77,000. This means the management could consider investing, for example, about £10,000 in a couple of bots that will still give you a robust business case to work off, saving about £50,000 each year. The last graph on the right is about complexity and variance of an activity. The orange graph on top looks like an attractive target to automate that will take out about 140 days of effort. However, the standard deviation on the right shows that it has high variance value of about 1.5. This means these activities may sometimes take a minute or other times an hour. This flags too many exception flows and complexity, and possibly not a place management should invest its automation budget. The purple bar at the bottom may be a better target as it will also save around 66 days. The variance is quite small at 0.5, so activities here are quite repeatable without much variance, and this should also be easy to automate with an RPA type of bot. If savings are targeted at $500,000, for example, these types of activities may be a better bet to focus the automation budget on for much sooner and better ROI. Thank you for watching. We'll close by saying that Enate RSO lets you get much further and faster with your automation program. For any questions, feel free to reach out to us at www.enate.net. That is www.enate.net.